Okay, the next thing about simple harmonic motion that we're going to look at is the energy transfer within the system. Now, if you'll remember from last semester, we used LOL charts to keep track of the energy transformations within the system. Because the system here is just going to be the system of the Earth, the spring, and the mass, all right, I'm actually going to leave out the O parts and just do the bar graphs for 4 parts of the motion. The top, the middle, the bottom, and then the middle again. So you can think of this as the middle on the way down and the middle on the way up. So for each of these, we're going to draw the L, and we're going to fill in the 3 columns. So there's gravitational potential energy, spring potential energy, and kinetic energy. So some combination of those at all 4 points. So then we'll fill in the columns for each of these graphs, and then we'll get started figuring out where these exist. So some of these are a little easier than others. So the place to start is we know that at the top and the bottom there's 0 velocity, which means there's no kinetic energy at either the top or the bottom. We also know at the middle there's some amount of kinetic energy, and it's the same in both directions, so let's call it 3 chunks. Remember that each chunk doesn't necessarily stand for any given value. Okay, so we also know at the middle there's some amount of gravitational potential energy, and if we call the gravitational potential energy 0 at the bottom, we can say the middle is 1 chunk. Okay, and that means the top's going to have some amount, but we have to come back to it later. We also know that at the middle there is 0 spring potential energy or elastic potential energy. So that means that there's 4 chunks total, so at the bottom there has to be 4 chunks of elastic potential energy because there's no other kind of energy. Again, at the middle, 0 elastic energy. So now we have to figure out what's going on at the top. So this is where it gets a little interesting because there is gravitational potential energy and there's actually less spring energy at the top than there is at the bottom, because the total energy has to stay the same. So here you'll see that there ends up being, say, 2 chunks of gravitational potential energy and 2 chunks of elastic potential energy. But remember, we're keeping track of relative changes, so that doesn't actually mean that the gravitational potential energy is equal to the spring potential energy at that point.